All right, welcome back to the second lesson of Term 3, Unit 1. This lesson is on problem solving, creating a quadratic. So remember, a quadratic is going to look like a parabola, so it's going to look like a smiley or it's going to look like a frowny. Okay, so I'm just going to scroll down. This is just review of a bunch of different things that you've already learned. The reason that we review so much is because, as you've noticed, you learn things in Math 1, you review them later in Math 1, you review them later in Math 2, and then learn more on top of it. Then you do it again in Math 3, and then learn more on top of that. And so it's just a big old repetition with adding on. So these are just all review graphs and equations. So I'm actually going to scroll down to this practice question. Create and graph the quadratic that represents the situation below. Brett is choosing an easel to make a painting for his sister's quinceañera, which is a 15th birthday party. Easels come in rectangular sizes where the width is 2 inches longer than the length. Write an equation to represent the area of the easel based on the length. So the first thing that we need to do here is we have to understand what this is going to look like. So it says the width is 2 inches longer than the length, okay? So that means if I make my length, let's call it L, that means the width is going to be L plus 2. 2 inches longer than the length, okay? So the question is just to write an equation. That's all it's saying, just to write an equation to represent the area of this easel. Well, we know the area formula is length times width for rectangles. It's length times width. So I have my, and it looks like in the example here, instead of using L for length, that they used X, and that's totally fine. So I'm just going to draw it one more time. Your length is X, and then your width is 2 inches longer. So it's your length plus 2 is going to give you your width. And then I'm going to write the equation because the task is to write an equation. So I know my area is length times width. So I take my length and then I times it by my width. And what's that little thing that we can do? Distribution. So I'm going to distribute this in. X times X is X squared. And then I get X times 2 is 2X. So if the task was just asking me to write an equation, that would be the equation for the area. Okay, so a lot of the questions on this quiz that you're going to see is not just asking for the area. A lot of them are going to be actually asking you to find the maximum area. So I'm going to add on to this question. So now my task is to find the maximum area of the easel. Find the maximum area of the easel. So anytime you have a quadratic, which we do, the lesson is creating a quadratic. Notice we have an X squared. That means that that's going to be a smiley or a frowny. Okay, and actually in this case, because my quadratic has a positive number in front of X squared, it's going to be a smiley like that. So there won't actually be a maximum. The maximum will be infinite. So I actually don't really like doing this question for finding the maximum area, but this question was good for setting it up. So I'm actually going to move on to the next question to practice finding the maximum area. Do you see? Because that's a positive in front of X squared. There's no maximum. That's going to go on forever and ever. So the maximum would be infinite. Let's do this one. Perfect. So you're creating a rectangular flower bed with side length negative 2x plus 18 and x plus 1. So those are the side lengths of this rectangular. This is my flower bed, my rectangular flower bed. Okay. My rectangular flower bed. What x value will give you the maximum area of the rectangle? So right here, maximum, that's kind of a trigger word. This tells me that we're probably going to be dealing with a quadratic and we want the vertex. Okay, and you'll see why in just a second, but that's kind of like a trigger for me to know that. So I'm gonna do it over here on the side, if that's okay. Oops, sorry, I'm gonna do it on this side. So I know that the area formula, once again, area equals length times width. So I'm gonna take the length, which is negative 2x plus 18, and I'm gonna multiply this by the width, which is x plus 1. And then I'm just going to use that magical thing that we all know, distribution, distribution, distribution. Okay, so I'm going to start distributing. So I have negative 2x times x, I get negative 2x squared. Then I have negative 2x times 1, and I get negative 2x. Okay, then negative 2x has multiplied each term in this parenthesis, so I know I'm done. I move on to the next term, which is 18, and I do 18 times x, which is just 18x, and then I do 18 times 1, which is just 18. So now that I've distributed it out, I'm going to combine like terms, which I see I have two like terms right there. So the negative 2x squared is going to stay the way it is. Then I have negative 2x plus 18. So negative 2 plus 18 is the same as 18 minus 2 is going to give me 16x, and then the 18 doesn't have anyone to combine with, so that's going to stay 18. So this is my quadratic to model the area. If the question was just asking me for the area function, that would be it. Okay, but it's not. It's asking me for the maximum area, which once again, we said it's a trigger word to tell us we're dealing with a quadratic, which we are, because look, we have an x squared, and we need to find the vertex of that. Okay, so the vertex is going to tell us the maximum. So let me just create a little bit more space for us once again. I'm just going to erase that. Hopefully this gives you a few seconds to write down some of the notes. You can always pause the videos, you guys, if I'm going too fast to take notes or to write down what you need to write down. Rewind if there's something you didn't understand. You can always pause the video. Okay, so because it says maximum area right there, let's see, let's do this in pink, maximum area. Hopefully you guys can see that. The pink is, oof, it's dark. I'm gonna redo that because I can see that it's very dark. Let's do yellow. Maximum area tells me that we're gonna be dealing with the vertex. And what is the vertex? So I noticed that this is a negative quadratic. See how there's a negative in front of the x squared term? That means it's going to be a frowny, because frowny people or negative people frown. So it's going to be a frowny, and the vertex, I also call it the nipple. The vertex is the highest point right there. Okay, so we know that this has an x value and a y value because all points on a graph have an x value and a y value, okay? If I were to ask for what point gives the highest value, what x value gives you the maximum, that would be asking for the x value. But if I'm asking for what is the maximum area, then that means I'm actually asking for the y value of the vertex. So I'm going to add on to here, this wants the vertex, the y value of the vertex. Okay, so the weird thing about math is that sometimes you have to do steps to get to what you ultimately want to get to. Like, for example, we actually have to find the x value of the vertex to even get to the y value of the vertex. So we need to find the x value of the vertex first, and then we can use that to find the y value of the vertex. So to find the x value of the vertex, we are going to use our trusty old little formula, negative b over 2a. And you're probably wondering, cool, Meryl, what does that even mean? Well, a is the number in front of the x squared. So in this case, a is going to be negative 2. B is the number in front of the x by itself. So in this case, B is going to be 16. If you needed the C value, that would be this 18. C is always the number chilling out by itself. So once again, A is always the number in front of the x squared. So even if these terms were out of order, A would always be in front of x squared. B is always in front of x. C is always the one without a variable with no x or anything, okay? So to find the x value of the vertex, you use negative b over 2a. And you're like, great, that's not what I need. I need the y value of the vertex. So once you find the x value, you can simply find the y value of the vertex by plugging in the x value into the equation. So that is our process here, okay? So those are like the two most important notes, and we're going to be reusing this over and over throughout the rest of Math 3, and you probably used it in Math 2 a lot also. But basically, anytime you want to find the x value of the vertex of a quadratic, you can use negative b over 2a. Anytime you want to find the y value of the vertex, all you do is you plug in whatever you got for x. You find that value. All you do is find that value, then plug it into the equation. So I would plug it in here for x and solve, or I would plug it into this one and solve. Either way, as long as you do your order of operations correctly, you should be fine. Okay, so now let's go ahead and proceed with this question. So I want the x value of the vertex first, which is negative b over 2a. And anytime I plug anything in, I always put parentheses around it. Negative b over 2a. And this is an example of needing to put parentheses. See how I have that 2 times negative 2. If I didn't put parentheses, you might think it's 2 minus 2. You know? All right, so now I'm going to simplify. Negative 16 over negative 4. And I know a negative divided by a negative is a positive, and 16 divided by 4 is simply 4. So the x value of the vertex is 4. But that's not what I wanted. I wanted the y value. I just know I have to use the x value to find the y value. So now I want the y value of the vertex. I take this 4 and I plug it in. So like I said before, you can plug it into this right here, it in factored form, negative 2x plus 18 times x plus 1, or you can plug it into the quadratic in standard form. So I have negative 2, I always put parentheses, 4 squared plus 16 times 4 plus 18. So I just use this equation down here, and everywhere there was an x, I simply plugged in that 4 that I got. And now I'm going to solve. If you solve this by hand, you guys, you have to remember order of operations. You have to do this 4 squared first. It's not negative 2 times 4 and then squared. No. Exponents first, 4 squared first, and then that answer times negative 2. Or if you use your handy dandy graphing calculator, then it'll do it for you. So I have negative 2 times, as long as you put it all in parentheses, squared, plus 16 parentheses 4 squared, or excuse me, parentheses, not squared, plus 18. So see how I literally just plugged it all in? This calculator will do order of operations for you. It's really nice. So I just press enter, and then I get 50. So that tells me the maximum area of this rectangle is 50. And that is the solution for that question. Okay, so I thought it might be a good idea to do a question maybe from the quiz, or a question that's similar to one of the questions on the quiz. So I'm going to go back to the quiz, and I'm going to go ahead. First of all, let's look at this first question. The height of a rocket is modeled by h of t equals negative 2t squared plus 12t plus 8. This one is already in standard form, meaning you don't have to do the distribution part because it's already done for you. So for this one, all you have to do is find the x value, which is negative b over 2a, and then plug it back into this to solve for the y value. So this one is nice because it skipped a step for you. Let's see. Okay, here's a really good one that tends to kind of confuse people a little bit. So I'm going to get my notepad. Go Beavers! Okay, so the length of a rectangle. So first I'm going to draw it out because I have trouble if I can't see it. The length of a rectangle is x. The length and width add up to 10 inches. Okay, so if they add up to 10 inches, that means this plus this is going to be 10, right? Well, doesn't that also mean that this is 10 minus x? Because if they add up to x, 10 minus x plus x is 10. So that's a way that you can set this one up. So here's the length and the width. Once again, they add up to be 10. So if I take 10 minus x for the width and the length is x, 10 minus x plus x is 10. Okay, I succeeded in what I needed to do. Then the task is, what is the maximum area of the rectangle? So the task is to find the max area. Anytime I see that word, max area, that means I want the y value of the vertex. Okay, so in order to do so, I have to find the area, which is length times width. So my area is going to be length times width. Now what am I going to do? Distribution. So I have x times 10, which is 10x, x times negative x, which is negative x squared. Okay, and now you might think, oh, a is 10. No, remember I told you that the a value is always the number in front of x squared. So what I like to do to make sure I don't mess up is I just want to rearrange these a little bit. So I'm just going to put the x squared first, so that I know a is that one. And obviously I could look at this and say, oh yeah, a is -1 because it's in front of x squared. But some people forget that it's the one in front of x squared and think it's just the first one, which is incorrect. But I like to rearrange it just so it's in descending order of exponent, biggest exponent to smallest, so that my numbers make sense. So a is always the number in front of x squared. So in this case, a is -1. B is always the number in front of x. So b equals 10. And this one does not have a c value. Okay. So now I know the x value of the vertex is -b over 2a. So what I'm going to do is I'm going to plug a and b into this equation, but I must use parentheses for anything that I plug in. So I have negative parentheses over 2 parentheses. So negative b, which is 10, over 2a, which is -1. Let's simplify that out. I'm going to get -10 over -2. What's a negative divided by a negative? It's a positive. 10 divided by 2 is 5. So that is my x value of the vertex. Now the question isn't asking for the x value of the vertex, it's actually asking for the y value of the vertex. So now what do we have to do to find the y value of the vertex? We simply take this 5 and we're going to plug it into our equation. Now you can plug it into this one here, or you can plug it into this one here. If you do this one, just be careful, make sure you do order of operations, or make sure you type it into your calculator correctly. So I'm just gonna do this one. I always put parentheses around anything I plug in. That's gonna be a 5. And I'm just gonna plug it in my calculator because my calculator does order of operations for me. So I have negative parentheses 5 squared like that. Make sure you put that parentheses around the 5, otherwise it might not do it correctly. Plus 10 parentheses 5, and that gives me 25. That means the maximum area of this, let's see, rectangle is going to be 25. So on the quiz, you would simply just pick 25 feet squared and then move on to the next question. So it looks like all of these questions have to do with finding the maximum area. Oh, here's one where it's just saying what value of X will give the maximum area. Okay, so in this case where it says what value of X will give the maximum area, that means that you are just gonna stop right here. If it's asking what value of X gives the maximum, then the answer is gonna be the X value of the vertex, okay? If the answer is asking what is the maximum area, then you're looking for the Y value. So let's add just one last little note that you guys can keep in your notes. If it is asking for X value that gives maximum, you want the X value. And you're probably like, yeah, it seems so straightforward, but some people get confused. If it's asking for what is the maximum area, that's asking for the Y value of the vertex, and that's the X value of the vertex. So if it's asking what is the maximum area, then you want the Y value of the vertex. If it says find the X value that gives the maximum, then you want the X value. So that's another really important thing that I think you should have in your notes, just to decipher what they're asking for, because if you don't know what they're asking for, how are you supposed to find it? All right, hopefully that all made sense. If you have any questions, go ahead and let me know, come ask me. But great job, you guys. Keep up the good work.